Hello, everyone, and welcome back to another Fusion 360 live stream. I am your host for today, Jason Lichtman, and today's topic is going to be surface modeling. For any of you that might have already watched our previous surface modeling class, which I called Introduction to Surface Modeling, this is going to be a continuation of that. This is going to be more of an intermediate level, so we are going to deal with some more advanced topics, but I'm definitely going to focus on making sure that they are going to be as clear and easy to follow as possible so that anyone can follow it. And then my goal, of course, is to follow this with another live stream that's going to be very advanced because there's not a lot of really advanced content that's out there, and I want to make sure to cater to that. So today is going to be intermediate surface modeling, and we do have a couple of things about today that are super special. One is that we have a partnership with a company called FXR Racing. They've provided the CAD models that I'm going to use today because I wanted to make sure that everything that we show you, you're going to be able to see in like a real application. So this isn't going to be, making any kind of hobby projects, at least for this particular live stream. I want to make sure you could see that you could use Fusion 360 and Fusion 360's surface modeling for very commercial applications. So FXR Racing has provided the CAD models. Also, as I'm sure you've seen in the title, we have a partnership with Makerbot, which provided the 3D printer that you see in the background right over here that I've been using for nearly all of my 3D prints and prototypes. And I'm going to be showcasing how you can use that Makerbot 3D printer to be able to prototype your surface models, right? By definition, surface modeling is all about having clean surfaces. And so having a 3D printer that can provide you with prototypes with nice clean surfaces is going to be super important. Anyway, those are two very special things about today. But we do have an official agenda. So let me go and pull that up real quick. Just a moment. Like we want screen. There we are. So in today's live stream, we're going to start off by showing you some new surface modeling tools in Fusion 360. They're new as of, I would say maybe 6 months ago at this point, but a lot of the videos that are out there that you might have watched are older than that. And so I wanted to make sure to cover the tools that might not be in other videos that are surface modeling specific. I'm also going to be showing you what I like to call the hidden surface modeling tools. I'll be covering what they are and also how to find them. And then we're going to be showing you surface modeling in action. That's the part that I think you're going to enjoy the most. And those are going to be the examples that I'm going to use the FXR Racing CAD models for. And then lastly, we're going to cover the Makerbot Method X carbon printer that I have in that background and how I use that for prototyping. So I think that's a pretty good agenda. I'm going to go and pull my camera on here as well. You can see me as well and all my fancy hand gestures. And we're going to jump right into the good stuff. So the first part of this is going to be those new surface modeling tools. And I'll give you a quick list of them right now. I'll tell you what they are, what they do, and then I'll show you in Fusion 360 where to find them. So the first one is ruled surface. It is probably my favorite of all the surface modeling tools, let alone the newest surface modeling tools. And ruled surface can create a surface that starts at an edge of another surface, and it can be normal to that surface, it could be tangent to that surface, and then lastly, it can also be in a particular direction. That's my favorite of all three. You're going to see me using that tool quite a bit in this particular live stream. The next one is going to be untrim surface. So if any of you have surfaces that are a little bit too small and you need to make them bigger, currently or in the past rather, you probably use the extend tool to extend those surfaces. The untrim tool will do that more automatically and is much faster in many applications. So I love the untrim surface. Parting line draft is an interesting one because parting line draft isn't really a surface modeling tool. It's more of a solid modeling tool. In fact, you will find it in the solid modeling tab. I'll show you this all in a moment. But the parting line draft tool, again, solid modeling, is used very heavily for consumer product design or for organic models like the ones that we're going to be working on today. And so even though technically it's a solid modeling tool, it really, to me, goes hand in hand with all these other surface modeling tools, because you're going to be using that to be able to create your geometry for those organic or highly stylized models. So let me show you where they are in Fusion 360. So let's jump over to Fusion itself. This, by the way, is a quick preview of what we're going to be working on in a little bit, the Squadron Goggle by FXR Racing. But just to show you where those tools are that we were talking about, it's primarily surface modeling tools. So you're going to want to go to the Surface tab in the Design workspace. And within this tab, under Create, you're going to see Ruled Surface. And where is it? Right there. And when you do go into Ruled Surface, you're going to see that you're going to get to pick an edge, which I haven't picked yet. And those three options I talked about are the normal, tangent, and then direction. And you're going to see me using this quite a bit again. So I'm not going to go and show you how to use it just yet, because you will see that, but just wanted you to know where to find that tool. And if you're going to use it as often as I do, you might want to put this at the very top where you could use that much more quickly. The other tool we're going to be using is going to be Untrim, but Untrim, you're not going to find that under Create. You're going to find that under Modify, and you're going to find that right here under next to Trim, you're going to see Untrim. So think of Untrim like the reverse of Trim, right? Trim is meant to make things smaller, and Untrim is meant to make things bigger. Very similar to Extend, but Untrim is going to untrim it in all directions. And typically, Untrim is going to untrim your surface to what that surface looked like before it was ever trimmed. So like the original surface. And that's going to be important as well. You can actually extend it even further, and you'll see that in a few minutes when we actually go to use that tool. And then in terms of parting line draft, I did tell you that that is part of the solid modeling tools. So if you go under the solid tab here, and you go to modify, you're going to see that we have our draft command or draft tool. And within this draft tool, you're going to see a second option here that says parting line. And this is the parting line draft that I was really referring to. So if you're creating parts that have non-planar parting lines, parting line draft is for you, and it is awesome. So those are the new tools. Again, I didn't actually show you them in action yet, but I did want to highlight what they are, and you are very much going to see them in action. The next thing I want to highlight are going to be the special tools or the hidden tools you're not going to see in Fusion 360 by default. So many of you that are newer to surface modeling probably didn't know these existed. So I want to make sure to highlight those as well. And so let's go to the next slide here. The hidden surface modeling tools include merge, validate, and then flip surface normal. So merge is going to merge two faces of a surface body together. I'll explain more in a moment. Validate is meant for kind of like doing an analysis on a surface. Like, are there any bad, is there bad math behind those surfaces? And it can actually fix them as well. We are very much going to use that today. And then flip surface normal is meant to flip the surface normal. But if you're not familiar with what that means, a surface has like a front and a back to it, even though it's infinitely thin. And the flip surface normal flips which one of those is the front and which one is the inside. And I'll admit, I never use flip surface normal. I haven't actually found a need to ever, but if you can find a good need for flip surface normal, please put in the chat. I would love to be proven wrong here on like a really good application for flip surface normal, but just know, of course, that that does exist. Now, for the merge tool, I wasn't going to show it in the actual examples that we had, so I'll actually show you the tool right now. Let's actually jump right back to Fusion 360 here. And I'm going to switch to maybe this model here. And I'm going to introduce FXR Racing in more detail in just a bit, but I'm going to skip ahead for just a moment so I could show you how to actually access these tools. So when you're in Fusion 360, you probably have noticed that you can have the design history on or off. So when you import something like a step model, like I have on my screen at the moment, there's no history on this model. And I know that because the very bottom of my screen from left to right does not show my timeline. And then also on the very top of my screen, I can see tabs for form, mesh, and well, no, nothing else besides that. Form and mesh are the ones that are showing up that don't normally show up. And you probably already know this, but maybe you don't. But the reason that form and mesh don't normally show up is because those tools are not parametric. So when the timeline is on, they kind of like fight, so to speak, with this parametric way of modeling, so we can't show them. And what we do to enable you to be able to use them is you would go to create and you would say create a form or create a mesh, and then it shows up as available. And in fact, let's actually show you that real quick here. I'm going to go and turn on my modeling history here. The timeline showed up at the bottom of my screen, and the form and the mesh tabs disappeared from the top. And if I did want to go into those workspaces or tabs, I would go to create form and you'll see the tab shows up. Or I would say create mesh, it's a little bit lower on this, and I would now see the mesh tab. But again, they don't normally show up. They're somewhat hidden, very much like the surface modeling tools I'm about to show you. So with the history turned on, you're not going to see these tools. But if I turn the history off by saying do not capture design history, and I'll ignore this warning here. Now, when I go into my surface tab and I go to modify, I'm going to see this merge tool that wasn't there before. And I'm also going to see the flip surface normals. And where is it? Oh, sorry, it's called reverse normal. I mislabeled it in my PowerPoint. But you're going to see these tools, and again, they normally do not show up. So just be aware that these exist, and they can be really handy. I'll show you the merge tool in just a second. And then there's another tool, the inspect validate tool. You're going to find that under inspect validate, and you'll find that right here. We are going to use the validate tool in just a little bit. So the only one I'll show you for now is going to be merge. And let's go and create a surface that I can actually use for this. So I'm going to go and grab, let's say, what do I want to use here? Look at this. I want to use these two right there. And I'm going to do a surface offset real quick. And I'm going to hide the solid body. So now we really just have two surfaces. By the way, if I'm using a bunch of terminology that isn't familiar to you, that's okay. It probably means you haven't watched the Intro to Surface Modeling video that I created. A link to that is in the description, so please make sure to watch that. I like to call it like required reading, so to speak, for the intermediate level that we're at right now. Also, if you have questions on any terminology I used, please feel free to put it in the chat. Jeff Smith from Autodesk is in the chat window right now, and he can answer any of your questions. And any questions that he is unable to answer or would be better fit for me to actually show off, I will show you those answers at the end of this particular live stream. All right, anyway, let's show you what merge does. So if you go to modify and you choose merge, you select two faces of the same surface body, and what it's going to do is merge them together. Now, when I first started using this, I assumed that if these surfaces are really the same surface, there's just a split in it, that it would get rid of that split, but it keeps the original surfaces. It's not exactly what's happening here. So I do want to make sure to give you a little bit of a warning that what this is really doing is it's taking the boundary around the surface body and creating a patch that's patching with that boundary. So it's not very different than just doing a patch yourself, except for the fact that it's way faster. So if I hit OK right now, it's going to go and create a single surface using that boundary. But the warning, the reason that that's important to give you a warning, is that if your original surface has like a very steep curvature to it, the merged surface may not have that curvature to it at all, because it doesn't have any kind of constraint in the middle of the surface to keep that like pop to that surface. So just be aware that it's really just taking the outer edge and merging or patching like a new surface between. But this can still be very helpful. I might actually use this in just a little bit. So that is the merge tool. And then the flip normal, actually, let me show you this a little more clearly. I'm going to go to my preferences here so you can actually see this a little bit better. In your preferences under graphics, there is a checkbox that I have checked right now that says display surface normal, disable surface normal display. When that's checked, I'm going to hit cancel. You're going to see that the surface looks the same on the front and the back. If, however, I turn that off, right, so I disable the disable, so to speak. Let's go and do that. I'm going to uncheck that box and hit OK and apply, or whichever method you prefer. Now when I look at this on the back side, it looks a little bit gold colored on the back, and it looks like normal colored on the front. That's just telling me which is the front and which is the back, or which is the outside and which is the inside of the surface. And what you can do with this reverse normal is you could select the surface, and now you're going to see the gold, in this case on the front, and the normal color, so to speak, on the back, right? So it flipped it. Again, though, I haven't actually ever needed to use this. So if you have a really good reason to use this on a regular basis, please put that in the chat. Again, I would love to be proven wrong, or better yet, I would love to learn something from all of you. That would be wonderful. So please do that. And then in terms of the validate, this one is really important to make sure that your surfaces themselves are clean. When you look at a surface, sometimes you could tell when something is off, you know, like when the surface is kind of like folding inside out. But oftentimes it looks just like a perfectly normal surface, but in reality, the math is bad. So when you're trying to do something like a surface offset and it fails and you're wondering why, and you're trying to tear your hair out, which I can't do very well, you're probably going to want to do this validate command. And so the way that works is you select your surface. You can choose a level of checking, like how detailed it's going to go. I pretty much always use standard, and I hit the OK button, and it's going to go and validate if the surface is a good surface. If there are problems, it'll tell you that there are problems. Unfortunately, it's not detailed enough to tell you where those problems are or how to fix them, but you could actually just go back to that inspect, validate one more time, and if you hit repair and then check that same surface, now it'll actually also clean the surface or fix it for you as well. So this is really helpful. Now, I've shown you that to get to these tools, all you have to do is turn the history off. But if you like modeling with the parametric history, that's okay too. You also have the ability to temporarily turn your history off. And to do that, let me show you how this works. You turn on your history, so capture design history, and then you can create what's called a base feature. You won't find it under surface create, but you will find it under solid. And if you go and say create a base feature, it puts you into this temporary zone that's not parametric. And in that particular zone, you could go to the base feature surface, and you should find the validate command. And under modify, you're going to find merge and also the reverse norm. So you don't have to turn off the history forever. You can actually just create a base feature and also access these same tools. So those are the hidden tools that I was talking about earlier. And now we've gotten to my favorite part of today's live stream. We are going to be talking about surface modeling in action. I'm going to show you some real examples of surface modeling. And as I mentioned at the very beginning of today's live stream, we're going to be using examples provided by FXR Racing. So I have to tell you a little bit about FXR Racing, and then we're going to jump into those examples. So FXR Racing is a consumer product company, and they make a lot of outdoor equipment for the motocross industry, for the snowmobile industry. They also deal with professional fishermen, or fisher people, I assume we would prefer to say these days, and also for just lifestyle equipment as well, or lifestyle clothing. There's a lot more to it than I can just describe myself, but I will say their website is absolutely phenomenal. So you can go to their website and see what products they have to offer. But also, I'm going to show you a video provided by FXR that really summarizes who they are and what they're all about. It's a summary of last year, 2020, and I'm going to start that right now. Hold, please. right, we are back. All right, so that was the intro to FXR Racing and what they do. As I mentioned earlier, they're a customer of ours, and we are going to be showing you some of the things that that they are doing on a regular basis with surface modeling in their products, and we're going to be using their products as our examples. So let's jump to Fusion 360 and actually show this off. And actually, we want to share our screen again. There we are. So let's go and take a look at one of their products. This one is going to be a goggle, and it's the Squadron goggle. This one is no longer in production, so you're not actually going to see this one on their website, but I still think this is a perfect example of a heavily surfaced product, and it's going to be great for our examples today. So let's actually show that. Right here you can see a picture. This used to be on their website. This is from their professional photographer. We're going to jump into the goggle itself. And we're going to go and focus on, let's say, this front view of the goggle and really take a look at what's inside. How is this constructed? If any of you have ever used goggles before, of course, you have a strap on the back of the goggle. We have a frame of the goggle that's actually holding pretty much everything together. It's the majority of the goggle. And then you have the lens in the front. You could see highlighted in very dark blue for a second. And then you have foam across the back. That's what makes it nice and comfortable against your face. And then there's also foam around the outside of the frame, and that's what's going to provide kind of more of like a solidified outside, but it still makes the goggle breathable through the vents that you're going to see from below. If I zoom in, actually let's hide the lens for a second. You'll see it a little bit clearly. We're going to be looking at these vents in particular. And of course, the foam is kind of like very porous, so air is going to be able to travel through it as well. Anyway, we're going to go and look at some surface modeling in this goggle and some problems that you probably face on a regular basis and how we're going to overcome them. Let's go and take a look for just a second at our PowerPoint again, and I'm going to give you a list of what examples I'm going to show so we can keep track of our time for today. The first thing we're going to do is we're going to show you how to stitch together good surface bodies into a solid. I'm calling them good for a couple of reasons you'll see in a few moments. I'm also going to show you what to do when you need to stitch bad surfaces together and make a solid. And those two examples are really going to cover what happens when you're importing what's supposed to be a solid from a vendor, a customer, from a client, from anyone, and you're having problems because they come in as surface bodies instead of a solid. Then we're going to start to deal with modifications. So moving a vent wall using surfaces and what I like to call the replace face method. And you'll see some advantages of that method. I'm going to show you a couple of variations there as well. And then we're going to jump into the more serious surface modeling. I actually have two examples for that. Depending on the timing for this particular live stream, I may be able to show both. I might only be able to show one. We'll see. I'm not sure yet. So let's jump into those examples, right? So I'm back in Fusion 360. I'm going to jump to the same goggle here. We're focusing on just the frame. And let's say I imported this from my customer or from my vendor. And when I look at the bodies folder here, I see a lot of surface bodies, right? Indicated by the orange instead of the white. And if I scroll down here for what seems like forever, oh my gosh, it looks like this is coming in as 970 surface bodies. That's a lot. And what we want to make sure to do is really just convert this into a solid. And to be clear, the reason that you might get this happening from time to time is not necessarily the fault of whoever sent you the file. These kinds of things happen regularly when you're translating from one program to another. It could be Pro Engineer to Fusion 360. It could be SolidWorks. It could be even Alias, our own Autodesk product, into Fusion 360. It also depends on whether you translated that file from, let's say you're starting in SolidWorks, you translate it from SolidWorks to an IGES or like a generic 3D model file, and then you bring it into Fusion 360. In that case, you actually translated that file twice. And in translating it twice, you have more room for error to come up with translation issues. Anyway, the fix for this is very simple. You're going to go to the Surface Tools, Stitch, and what I like to do personally from the very beginning is change my tolerance to 0, and I'll explain in more detail why in a moment. And then I like to use the box select, but you could use any of the selection tools here that you prefer. And I like to box select around everything in this model. So basically all of the surface bodies. So I don't have to pick them one by one because I don't have enough time to pick 960 surfaces one by one. It's just a waste of life. So I box select over everything. It's going to figure out if it's going to be able to stitch everything together. And what I'm looking for here is these numbers, right? So it says there are 5,190 free edges. And according to these settings that I picked, it's going to stitch 5,186 of them. There are 4 edges that are not going to be stitched. That's not a good thing. I want all of them to be stitched. And so what I'm realizing here is that I opened the wrong file to show you this. I have one prepared with what I called good surfaces. Let me switch to that and do this again. So same idea, surface, we're gonna do stitch. I'm going to change my tolerance to 0, and I'm going to box select around everything. What I'm looking for and expecting this time is that that number is going to be 5,100 and whatever that was. It'll be the same number for the free edges and the edges that will stitch. There it is, 5,174. And so if these surfaces are good, meaning they have really good boundaries between the different surface bodies, there's no overlap that shouldn't be there, everything is good, then all I have to do is hit the OK button and it will stitch everything. And what I should see in a moment under the bodies folder is instead of a whole lot of different surface bodies, I should see one solid body. And that's really what I'm after. And it names it something random like body 972, and I would just rename this frame. And if I want to be more anal retentive, maybe add solid there. And this is looking good, right? So this is the best case scenario. But what happens in that other scenario? So let's go back one more time. I'm going to do the same thing like I did before, and I'm going to highlight everything, and you're going to see, just like what happened a moment ago, not everything is going to stitch, right? There are 4 open edges that are not stitching. So what do you do in that scenario? Well, there are a couple of things you can do. The first thing I want you to notice is that I did set the tolerance to 0. And what that means is that if the edges or boundaries of those surfaces aren't touching perfectly, this won't stitch, right? Because there's no tolerance that I'm allowing for. What you can also do is increase the tolerance. And if you increase the tolerance, it can fix some of these problems. In many cases, all of your problems automatically for you. But just know that you could potentially be creating different problems by cranking up that tolerance too high. So I start off at 0 just to check if those surfaces are clean. And if they're not, then I increase my tolerance a little bit. Something like 0.1 millimeters if you're in metric, and if you're in imperial, probably like 50 thousandths of an inch, something like that would be fine. And what I'm looking for here is, again, do the numbers end up matching? And in this case, it gets really close, but not all the way there. And there's still one edge left, and if I select this edge, it highlights it. It was a little hard to see, so I'm going to zoom in here so you can see that again. When I selected this edge, it shows me which edge is the problem. And it's that one right over here. So if I cancel for a second, now we're going to be able to see why it's not actually stitching in the first place. And when I stop moving my mouse, you'll see everything highlighting nicely. There's a gap. And that gap is bigger than my tolerance, which is why it's not able to fix it. If I make my tolerance high enough, it would potentially fix it. But in some cases, the fix is really creating other problems. So I just want to give you an example of that. If I zoom out a little bit and we look at this goggle, there are a couple of edges, and this one in particular, that are a great example of that. And to be clear, this is not the fault of FXR Racing as a product design and development company, or whichever factory FXR Racing is using. This is normal stuff that happens when you translate from one program to another. Your goal is to avoid these problems and fix them, but just know that this is very common, and so there's 0 blame coming from me whatsoever. But the problem surface here is that this surface And this one, where they meet, should be a nice, oh, I zoomed in too much. There it is. It should be a nice fillet. But if I zoom in here, you're going to see that there's some like weirdness going on. And actually, when I opened up this model earlier, I was seeing that it was kind of like flipping inside out. Actually, this model shows it a little bit better. Again, same model, just different file. Let me zoom in so you can see it a little more clearly. Wait for it. There it is. Wow, there it is. You can kind of see that right over here, and then over here, it's kind of like an hourglass shape happening, but it's crossing itself. That's not good. That's not what you want at all. And this is the kind of thing that happens when you try to crank up that tolerance too high. So I would encourage you to start off with it at 0. And if you need to increase that, increase it a small amount, like 0.1 millimeters or 50 thousandths of an inch, and then crank it up little by little until you're happy with what you want. Let's go back to our other model here, and I'll show you that in action. So let's try this one more time. We're going to go and stitch this. I'm going to select everything. I'm going to leave my tolerance actually at 0 for now, and I'll let this stitch whatever it can, and we'll show you what you could do to actually fix this model. And there are 2 techniques I'm going to show you. One of them is like the proper fixing the surfaces. The second technique, which I'm going to show you that one first. Flip. But the second technique is really cheating because this particular model happens to be symmetric left to right, and all the problems I found here are on one side of the model. So why bother trying to fix those surfaces when I could really just use the other side? It's perfectly fine. So let's go and hit the OK button. It's going to stitch everything that it can. And what I'm hoping for is 1 surface body, 2 surface bodies, 3, less than 10 would be wonderful, right? Because the more of these you have, the more fixing you have to do. And in this case, oh, look at that, just 1 surface body. If I try to stitch this a second time, which might sound counterintuitive, but that's my technique here. I try to stitch this a second time, and when I do that, it's going to calculate pretty much the same thing that I had before, but it's going to calculate it much faster because it's only 1 surface body at this point. So now what it's telling me is that I have 8 free edges, and if I leave my tolerance at 0, it's not going to stitch anything. But also, you can see in red, this area here is very much not stitching, and this area down here, oh, zoomed in too much. There it is, also not stitching. And if you stop moving your mouse and stop zooming and stuff, it will highlight it nicely in red for you so you could actually see it. You can also select them here and it will highlight the specific edges. It shows you in yellow which edge is the one that you're highlighting. So let's say I get it, right? There are 2 different areas that are problematic. How do I fix this? So let's do the second method first, the cheat by using the side that's good. For that, what I'm going to do is I'm going to create a quick sketch on the right plane here. And I'll just draw a rectangle that's bigger than my model. And I'll exit the sketch. And under surface, I'm going to create a patch using that rectangle that I drew. That easy. There we are. So now that I have that rectangle, I'm going to use it to chop away the bad half of my model. And for that, I'm going to use the trim tool. So I'm going to use this as my trimming tool. And then it's going to ask me, what do you want to remove? And I'm going to say, remove everything on this side. It highlights it in red, nice and clean. That looks great. And I hit OK. So all the bad stuff gone. I don't have to deal with that anymore. And so now how do I turn this into a solid? Well, I have a surface that's going to fill in the empty space, right? If I hide that, you'll see that this is all empty or hollow, so to speak, right? It's a surface. And if I show that again, all I really need to do is to trim this so that I have all the surfaces I need to stitch together into a closed volume. So what I'm going to do here is I'm going to say trim. This time I'm going to use this object or surface body as my tool. And I'm going to select this in red. And I want you to notice, let's go into right view so you can see this better, that the red part is everything besides these 3 areas. Like it filters out that based on my selection. Could I also select these? Yes, but I don't want to because I want to keep them. So I'm going to hit OK. And now what I'm left with, the white surfaces you see here are the trimmed surface from that flat rectangle that I made. And from what I see here, everything that I'm doing is like closed, right? There's like no emptiness. So all I have to do is to stitch this all together and I end up with a solid. So I'll go and hit the stitch tool, select everything that's in here, or manually select them all from my list. I see there are 96 edges. All of them are going to stitch. And when I hit OK, this is now going to be a solid. Awesome. That's what I wanted. And so now what I would do is I would go to create, do a mirror, select this body, mirror it across the center line, and then I'm back with a full goggle. Join this together, and I'm back with a full goggle. And now I don't have to worry about filling in those problems. But what if, for whatever reason, you can't do that, right? Maybe your model isn't symmetric, and so that's not going to work for you. So let's go back. Let's do the undo command a whole lot of times here. Almost there. There we are. Okay, one more. There we are. So now we're back to the surface body. It still has this hole over here. It still has the hole over here. And let's go and fill them in. So what you could do in this case is under surface, let's exit our sketch there. Try it again. There we are. So let's go to create a patch, and I can just patch this boundary. And if I want to control, how smooth everything is, I could change connected to be, let's say, tangent. And I could also say group the edges, meaning make everything tangent. And I could say, okay. Now I have a surface. It's showing in white, right? But for all intents and purposes, it's really close to that original fillet. Theoretically, it's not the original fillet. It's slightly different mathematically, but it's close enough that the reality is no one would ever see the difference, especially for something like this size. If you wanted to be a little bit more, retentive, or like do this more accurately, you can also, let's go and delete that surface for a moment. You could also do something like a loft. And oftentimes when I see people doing loft, they're using loft to create these like very crazy swoopy shapes for all sorts of reasons. But you could also use loft for a feature like this. So I could loft from this fillet edge to that fillet edge. And then I could use this edge here as a rail. And then this one at the top as a second rail. And I can control my tangencies and stuff like that. And when I hit OK, again, I'm left with a very similar surface to that original fillet. It's still not the original, but again, no one's going to notice. And this might give you a much better result than just the patch tool, depending on the geometry that's around it. I just want you to know that that's available. You could also do that same thing one last time. We'll go and do another loft. And this time I'm going to loft from the top edge to the bottom edge. I can go and use the filleted edge as my rail. I'll go and add a second rail, this one right here. That looks pretty good, and hit OK. And this is the third iteration of doing this fix. And again, this is looking great. I'm pretty happy with it. And then I would just stitch this all together. The next thing we're going to do is focus on this area. And this one's going to be a little different, right? Could I create a patch? Absolutely. I'll just go and make a quick patch, hit OK, stitch this all together. This would be fine. But the reality is that this is a pretty close to flat, if not flat surface. Let's do a double check. I like to right click on things or faces, and if I see create sketch, I know it's flat, right? So instead of doing like the inspect tool, I just right click, and if it lets me make this into a sketch, it has to be flat because you can only create sketches off of flat surfaces or faces or planes. So this one's very much not flat as it turns out. And also let's get rid of that patch because we're going to do this properly. So how do you fix this properly? What I want to do is to take this surface face that I highlighted in blue, and I want to extend it until it fills in that area. But I don't want to do it via patch. I want to do this with the original surface. So to do that, I'm going to say that we need to separate some things here. We need to split this up a little bit. Just like we were stitching things together, you can also unstitch or split up things. Now, you've probably done split using split face or split body, but you can also split surfaces based on the faces that exist in it by just saying unstitch. So I'm going to choose the unstitch command, and I'm going to select this face here that I want to unstitch or separate from everything else. And when I hit OK, you're going to see an additional surface body in my list, just like that. Really easy. Now, to make my life easier so you can all see this more clearly, I'm going to color this something different so you could actually see this a little bit better. I'm going to color this something like kind of, no, blue's a little too harsh. Let's go with red. And I'm going to color this red so you could see what I'm doing relative to everything else. So we're going to go and use the extend tool. And the extend tool is going to extend a specific edge. So I could pick just this edge or just the side edge and extend it. And I'm going to drag that blue arrow or type in a number, whatever you prefer. But the key is that I'm extending it a little bit more than I think I need to, right? A little bit past. What I want to do at this point is to trim this. And what you might try to do at first is say, well, let's just use the trim tool. I'm going to select the goggle surfaces, and then I'm going to go and select that area I want to get rid of, which I'll admit is kind of hard to select right now because that other surface is kind of blocking it. But what you're going to find is that especially when we're talking about surfaces like this fillet that's like nice and tangent to the surface you want to chop or trim, it can be really difficult. It doesn't always necessarily trim the way that you want it. So what I like to do is to create a new surface that's just my trimming tool. I could also use a sketch, by the way, but I like to have my 3D surfaces. I find them to be more accurate because the sketch is two-dimensional, usually, and the surface is typically very much three-dimensional. So now we're going to start to use those new tools that we talked about. So under Create, I'm going to go and grab the ruled surface, and I'm going to show you what we're talking about on how this tool works. I'm going to go and select this edge right over here, and right now it's set to normal. And so when I drag this blue arrow, there, I want to tilt so you can see it, it's creating a surface that's normal to the surface that contained that edge. So in this case, it's actually the fillet here. And this surface that I'm creating is normal to that, to that surface. If you, let's actually hide that for a moment so you can see what else I could do. I could also change this to tangent, and it will be tangent to that surface. And then the last thing you could do is direction, and this one is my favorite. It's not really applicable to this situation, but you can pick a direction, like this would typically be like a draft direction for me, and I can make my edge follow that direction, and I could also tilt this, which means I could do my draft for injection molding or for foam molding or for carbon fiber molding or any number of different things. I will show you this again shortly, but for this purpose, we're going to go and use normal. I'm going to drag this to be out just a little bit, and I'm going to hit OK. And I'm going to hide this main surface, show you that one that we wanted to trim, the red one, and I'm going to go and use that as my trimming tool. I select this surface, and when I go to select the top, notice how it's kind of selecting everything. It's not really chopping what I want it to. And the reason is because whenever you're doing surface trims and things like that, you typically want intersections between those surfaces. That's going to be the real winner for any kind of trimming that you're doing. And right now, even though theoretically this edge is the same and they should be touching each other, I prefer overlap or interference on purpose. So what we're going to do is we're going to go and use the extend tool, and I'll select the inside edge of that ruled surface and just drag that a little bit. Now I could see a nice clean intersection of those two surfaces, and I could use this as my trimming tool, select the top, and hit enter. There we go. That's what I wanted. So now you might be wondering, what on earth am I going to use this thing for? Am I going to stitch that with the rest? Absolutely not. I don't need it for anything anymore. It's really my tool that I used to accomplish what I wanted. Think of this like scaffolding on a building, right? The scaffolding should not be there when you are done with your construction. The scaffolding just helped you do the construction. I did that construction. I don't need this anymore. Delete it. And I just hit delete on my keyboard. Now that I've done that, let's go and look at our surface again. And that, even though the colors are different, the reality is that this surface, whoa, zoomed in too much. This surface is terminating exactly on that edge and is looking great. So now let's stitch this all together. Select everything with my box select. I have my tolerance set to 0, and I'm gonna go and hit OK. I'll admit that right now it said that it's not gonna stitch everything. I'm a little surprised actually. Let's go and do another stitch command, select that same surface, and let's see where the problem is. And it seems like there are a couple of problems here. Let's go and find them. I'm actually not seeing it. Oh, there it is. So like this would be a perfect example of like when I'd pick the tolerance and move it up. Because the reality is, at least from my perspective, I created these surfaces to match exactly where they should. So there's something funny going, no, I see. There's a little bit of an edge problem right here. And so this would be a perfect opportunity to either go back and do that same thing again and extend it not only up, but slightly forward, and then trim using this edge as well. Or in this case, if like that gap is really, really tiny, then just up your tolerance a little bit. I'll put in 0.1, which I had recommended earlier. And let's see if these numbers match. Oh, that's great. Hit OK. And it's going to just fix everything for me. A small tolerance of like 0.1, perfectly fine. But if you're going to be setting that to 5 millimeters, you are going to run into a whole bunch of problems. So just be aware of that. And now, of course, I have my solid. Let's do a quick little time check here. Oh my gosh, we are getting out of time. I'll tell you what, I want to cover all this stuff. So we're going to go a little bit long today. And we're going to get to the next thing. And the next thing was, let's do a little double check, moving a vent wall using surfaces and replace face. So what do I mean by that? We talked earlier about how solid modeling is faster than surface modeling. So trying to keep the solids whenever possible is better, is faster, and it's a lot easier. So this technique I'm about to show you is what I would call a hybrid of surface modeling and solid modeling, because we're going to use surfaces, but we're going to use solid modeling tools to fix our model. So let's jump back into Fusion and you'll see what I mean. Let's start with a solid. Okay, so like this is our same goggle again, the FXR Squadron goggle. And what we're going to do here is we're going to mess with these vents on the top. But I don't want to double my work. So I said earlier that this is symmetric. So the very first thing I'm going to do here is I'm going to go and create a sketch. And we're going to go and chop off half of this model and only work with half. So I'm going to go and do a quick extrusion here. We're going to extrude this in both directions, something like this, and hit OK. Perfect. And by the way, the surface modeling I did a few moments ago, I did all of that with the history turned off. I'll admit, I mostly surface model with the history off. And I know right away that a lot of people out there are going to think that I'm crazy for saying that. There are some good reasons. I'm going to show you what those reasons are by turning the history on. And for this exercise, we're going to use our history. And then when you see how ugly and terrible and long that history is for absolutely no reason, I will then show you why surface modeling without the history is perfectly fine. So let's turn on our history, capture design history. There we are. And let's look at this vent right over here. So what I'm trying to do at this point is I'm trying to move this wall backwards, and I want to move it so that it's exactly 2 millimeters from this surface here. Now, could I create a sketch and project probably this edge and offset that 2 millimeters and use that to do a solid modeling cut? Absolutely. But what I'm trying to do here is I'm trying to make it so that this surface, whatever tilt it is, I get that same tilt in my vent. And for now, I'm ignoring draft for actual manufacturing, but just say for a moment here that I want that tilt to be exactly the same so it looks like super, super awesome. So how am I going to do that? Well, I'm going to take that surface I highlighted in blue, or that face I highlighted in blue, and I'm going to create an offset surface. And many of you out there probably have found this. There is a bug in Fusion that drives me crazy. We haven't fixed it yet. And I'll tell you what it is so that you can at least avoid it, is that we have a checkbox here for chain selection. When this is checked, when you select something, it should chain anything that's tangent to it. You'll notice that when I select right now, it's actually already doing that, even though this isn't selected. So the trick to fixing this, or at least avoiding it, is to check the box and then uncheck the box. That can be done very quickly. It's, check, check, and it's done. And then now, even though it didn't show it checked before, now it actually isn't acting like it's checked. So I'm going to say, sorry that bug exists. I am working to get them to remove it, but right now it exists, so I want you to be able to avoid it. So I selected this face, and what most people would probably do is to offset this. I think I said 2 millimeters, and you have it offset. My recommendation is to offset it by 0, extend it however much you need, because you're going to have an easier time extending surfaces that are not offset, and then to offset it after. That's personal recommendation, my best practice. Jeff Smith is on the chat window. He can confirm if he also does that or if he thinks I'm crazy too, but you could ask him in the chat window. So I'm going to set this to 0. There it is. And we're going to hide our original solid for a second, and I'm going to extend this surface. Now, if I want to extend this in all directions, I'd have to pick all these edges, right? And then I drag that arrow and it will extend. Or if you want to use some of our newer tools to make your life easier, untrim. So modify, untrim. Where did it go? Here it is at the top. Select the face, and it will untrim to its original before it was ever trimmed. And I know you might not have ever seen what the original looks like, but this is what it would have been. Like mathematically, this is the original. If you wanted to extend even further, you can also add a number here, and it will be even bigger. It doesn't always work. It depends on the math on the surface, but generally that's how this happens. I'm going to go and hit OK. Now I see my original solid again. I'm going to do an offset of this extended or untrimmed surface, and we're going to move this 2 millimeters and hit OK. And you'll see here that there is a little bit of an interference with the original surface, which is fine, doesn't matter to me, at least not for now. And what I want to do here is replace this face there, the blue one, with my new one. For this to work, the new one has to be bigger, which is why I was doing this extend or untrim method that I was doing. And so I'm going to go to solid, because again, replace face is a solid modeling tool. Modify, replace face. I'm going to check this face here is what we want to replace. And then my target is what we want to replace it with. And let's wait and see if it works. Give it a moment. There it is. And I go and I hit OK. And for any of you that come from other programs like SolidWorks or Creo, I bet that you're looking at this and saying, how on earth did that actually work? Because those fillets that you see around here, let's hide all these surfaces again. These fillets, this one here, this one there, and this one in the corner are typically going to make that impossible. But in Fusion 360, our kernel, or like the math or brain that we have in the background, is really, really good. And so it's able to calculate this despite that. Not always, but in many cases it does. If for whatever reason it fails, like it doesn't work, the trick for you in that case, let's go back one step here. So this is the surface I want to use to replace it with, is to get rid of the fillets. The fillets are not your friend. If you see a fillet walking down the street on your sidewalk, you move to the other side of the street. Fillets are not your friend when it comes to surface modeling. They are great to make your model look smoother. They're great to make your stresses in your model not propagate. But when it comes to making edits, they are not your friend. They will make your life very difficult. So you can get rid of them by selecting those fillets right here. There we go. And if you're in the solid modeling tab, just hit the delete button, and Fusion will do a really good job of getting rid of them. I'll also do the same thing with this fillet here. And now I'll try that replace face command, same like I did before. It will replace that surface with the new one. I can now hide or get rid of the original surface. Because my history is turned on, don't use delete, use remove, and it will just remove it from the timeline, but not delete the original. And then now I could go and add the fillet back in. And I'll admit I didn't pay attention to what size that was. Oh, that's way too big. It's probably like 1 millimeter. And then the fillet up here is probably like half or maybe a quarter. Close, or at least for now it's good enough. And I'll go and add those back in. So if replace face doesn't work with the fillets, you can also remove the fillets and then again use replace face. So this is a great technique to be able to use what I call hybrid modeling, where you're using surfaces or creating surfaces, but then still using solid modeling. Now I'm going to take this a step further. I'm going to complicate it a little bit because the goal here is to be able to up-level all of you out there. So let's say I want to do the same thing with this vent here. So if I use the same technique as before, and I'm going to do this again on purpose so you could see what's happening here. Double click on the chain selection. I pick this guy. I untrim it, right? That happened nice and quick. I extend this 2 millimeters. What do I see here? I see that the shape here actually doesn't match this one at all. And I wondered to myself, why? Oh, and I know why. The reason is because I did an offset of just this face. And in reality, there are two here, and I really should have done both. So let's do it for both. Offset by 0. Oh, I don't want everything. Try that again. Just these two, and I hit OK. I'm going to hide this for a moment so you can see what's happening here. I'm going to try the Untrim tool, and you're going to notice that it won't let me select anything. So to be clear, the Untrim tool is limited to individual faces. If you have a surface body that has 2 faces, and you could tell that this does visually, but it also says the number 2 here, telling you there are 2 faces, Untrim will not work. Just tell you flat out, it will not work. So the trick is to go back to the Extend tool. I'll go and select my edges. I'll do the same thing over here. And there we go. Excuse me. So now that I have my extended surface, I'll do an offset of that original. We'll do 2 millimeters just like before. And now we're going to do that same replace face. I'm going to choose this face right over here. And then for the target, this is a little bit funny, I'll admit, but when you're choosing the target, if you choose it from the graphics window, it's going to assume that you want just that one thing and not this entire body. So the trick there for multi-face bodies is actually to choose it from the browser on the left. And that will choose it as like an entity, as like a group. And in this case, it did it, and this is looking fantastic. That's exactly what I wanted. So this is similar to what I did before, but repeating it with a slight twist so you see what's happening. Now we're going to get into the really hard stuff, and I have to really check my time. I'm going to go over a little bit, but I have 12 minutes before I have a hard stop. So we're going to do this a little bit faster than I would have liked, but you're going to get a real taste for what surface modeling can really be all about. Oh, and I do want to incorporate real quick the Makerbot Method X into what we're talking about here, because when we talked earlier about, doing the whole point of doing all these surface models is to have a great product that looks fantastic. So part of that means prototyping early and prototyping often. And so you don't always have to prototype full-scale models. You can actually prototype smaller models. This is the same model here, the Squadron goggle in 50% scale. So it looks really tiny, but the benefit here is that this prints way faster. 50% in width is also 50% in height. Well, not always, but in this case, 50% in general is 50% in width, 50% in height, and 50% in depth, which means 1/8 of the volume, which means 1/8 of the material, which means about 8 times as fast to print. That's awesome. This printer, the Makerbot Method X Carbon that I have, is a fast printer and prints great. Actually, I've had a lot of printers in my life. This is by far the best printer that I have had in my own home that I could print on anytime that I'd like. I've used some commercial grade monster machines that I mean, they're commercial grade monster machines. They're awesome. But oftentimes the prototype shop that I'm using has a backlog or a queue, or I have to wait 3 days for it to print. I have to wait for shipping. Having a printer like this in your house is a game changer. And I'll actually show you, I printed the full-size goggle, and I have that right here. The bed of this printer actually is magnetically attached, so all I have to do is pick it up. There it is. And here you can see a full-size goggle. That's the Squadron goggle right here on the bed. The white that you're seeing here is the support material, and I'm using SR30. It's the stuff that you have to use like a tank to get rid of, but it is amazing, especially for the high-end materials like nylon or ABS, or in my case, nylon with carbon fiber, a nylon 12 with carbon fiber in particular. And what that means for me, well, let's actually get this off the bed. I'll show you what that means for me. There we go. Almost. There we go. Cool. All right, that easy. What that means for me is that I get a part that stays put where it's supposed to, and I pretty much never have to worry about prints going bad because the part shifted or there was warping. This machine has a built-in heated chamber, and of course is a high-end nozzle that is able to print nylon with carbon fiber, and also able to print this SR30. And the result is great parts every time. And if I want to set this up for printing another job, which I do, there it is. Turn that back on. And we're going to have another print starting in just a second. You'll see that in a moment. So it's going to heat up the chamber for us and then start my print. But in the meantime, let's go and do our surface modeling. And we're going to have 8 minutes left for this. So far, I showed you that we have this parametric history. I would actually urge you to really think about, is this history important? What's the likelihood that I'm going to go back and change that offset to another number and it's not going to blow up my model? If you are doing something more complicated than just moving a vent, chances are that this is going to blow up. So, excuse me, what I do personally is I do a lot of my surface modeling non-parametrically. And keep in mind that you can choose what you want to be parametric and what you want to not be parametric. I started with a step model, and that step model shows up in my history. Let's actually show my history. I'm not showing my screen yet. There it is. Okay, so we're back to the goggle. You see the history at the bottom. And the very first thing you see here is the base feature that's really the imported geometry. And what I showed you earlier is that that base feature is actually the non-parametric temporary zone. So if I wanted to edit or create surfaces and I don't care about the history, all I have to do is right-click on this base feature and hit edit. And this is going to allow me to be in this base feature mode where there's no history and I could do all the surface modeling I want and not worry about the history. So what I want to do here is to start editing this area here at the front. And I want to tweak the angle on this a little bit. So we're going to actually go and tweak it. But to start this off, what we're going to do is, first of all, copy this solid body, because I might end up needing to reference the original as I'm going. So I'm going to hide the original, and we're going to call this edited or something like that. And I'm going to start to unstitch our bodies just like we were doing earlier. And this is the surface we're going to really tweak, but it's going to affect everything around it. So I'm going to unstitch anything that it might need to affect. So this fillet is definitely going to go away. We're going to have to rebuild the fillet. We're going to get rid of this as well. Just like that. We also want these surfaces down at the bottom. That looks pretty good. Zoomed in too much again. Sorry about that. I'll also do this surface right there and this one. There we go. So that's everything that I care about, and I'm going to go and hit OK. It's going to convert this all to surface bodies. That's fine. And I'm going to select something in the background that I don't care about for now and hide it. And then I'm going to stitch together these three things so it's a little easier to show or hide them. I'll do the same thing with these three, and we'll go and select and hide it. We'll do the same thing with these three, and then we're going to go and hide that as well. hide the thing in the middle, and these fillets, they are gone. Toast. Don't need them. Don't care about them. So now we have these three surfaces, and what we really want to do is to extend everything so that they match, as though there weren't a fillet. If you could do this in the solid modeling environment, that'd be much faster. So we're going to go and select these edges right here, and I'm going to go and drag this up, and it's doing something weird here. So let's try this again. I'm going to select just this area right there. Sorry, there it is. Yep, and we're going to extend that a little bit. Then I'll go and extend this one. Oh, it's doing something weird there. That's okay. I can even unstitch it from the surfaces next to it, and then extend this as well. And so now I have this like kind of weird stuff going on here. And again, we're going to go and trim this. Right? It's all about extending past and trimming. And now that I've done that, I can go and stitch this back together. Now I want to highlight that when I tried to extend it, it failed. And all I had to do is unstitch the surface and then extend it a couple of times, trim it, and then stitch it back together. It's really that simple. It takes a couple of steps, but that's perfectly fine. I'm also going to do the same thing with this surface over here. That looks a little weird, but I don't really care about that area, so it doesn't matter to me. I'll also go and grab these edges here. There we are. That's looking pretty good. And I'll also go and grab these edges over here. And again, what I'm trying to do is just have everything extend past itself. That looks pretty good, except for this bottom area. And I'll go and extend that also. Yeah, there we go. Now that we've done that, we can actually trim everything. So if I use this as my tool, I could trim away. No, that was a little weird. We'll do that again. I'm going to switch it up for a moment. We'll go and trim the top off. I'll go and use the bottom and trim this bottom off. That looks good. I'm going to go and use this to trim this area. That looks good too. And let's try this one again. This is the one that was being weird a moment ago. Still being weird. And remember what we did when we were trying to extend and it was being weird? Untrim it. Totally fine. Then we'll go and try this again. And we'll trim this off, this one off, and this one off. And I have to pick these separate because they're separate surface bodies. Totally fine. There we go. This is looking great now. But what we're really trying to do is not to just stitch this stuff for the sake of stitching it. We want to replace this surface with a new one. So this fillet is not going to work. We're going to delete that. This is what we're going to replace. Let's hide that for a moment. Let's go back to my ruled surface that I love so much. And we are going to select this edge. And we don't want normal. We don't want tangent. We want direction. And I could pick any direction I want, including, in this case, this edge of the original. Pretty cool. At 0 degrees, it's basically going to just follow that original. But I could also change this and say, you know what, I want 5 extra degrees down relative to that. I extended this a little extra, so I have what I want there, and that's looking good. The original, I don't need it anymore. It's gone. There it is. And now we're going to go and extend this just a little bit. Now, if this fillet that we had there, the original, so to speak, were a real fillet, I would extend this surface and this one here, get them to merge together and just add a fillet. But I know that that's not what's really happening here. What's happening here is that this model is actually trying to make the fillet match this top fillet and this bottom fillet exactly. So it's really not a fillet, it's more of like a loft. Like this is like a real application of a loft versus some others that I've seen. What we're going to do is we're going to create that. And for this, I'm going to unstitch. Again, I know I'm going a little faster than I would have preferred, but I'm going to do some trimming here. I'm going to trim this bottom edge here and hit OK. That looks pretty good. I'm also, actually, that one's looking pretty good too. So let's go and create a quick sketch. This is going to, I'm going to use the sketch this time to trim what I am making. And I want to project that vertex right there. Yep, that one right there. With this one right over here. You should see 2 pink dots show up in a second in the background. And I'm going to draw a quick line connecting them. And I'm going to connect the line to the dots. There we are. And I can use that also as a trim tool. So I could use this line and get rid of this section here of my surface. And that's looking pretty good. I can also go and trim the bottom of that surface using the bottom edge right there. And now we're going to go in Loft between this one and this one. Oop, let's add a little bit more. There we go. We'll go and change our tangencies. There, that's looking really good. And I'm going to go and hit OK. Actually, before I do, there's some options here that I like to mess with. And align edges will get me a little bit closer to what I want. I'll go and choose that too. Now remember, when you're trimming, you always want things to extend past, at least just a little bit. So what I'm also going to do is I'm going to hide this top here, and I'll extend this just a little bit. Yep, a millimeter is fine. I'll show that surface again, and I'm going to extend that one forward just a little bit. That's looking great. And I could use them to trim each other. So trim this using that. Okay. Trim this one using that one. Okay, great. And then the same thing down below. We'll do a quick extend here. Are we on time? We're going to run a little bit late. Hit okay. And do the same thing over here. Perfect. Trim these up just like we did at the top. Perfect. Now this is looking really good. We're almost done, by the way. We also need to trim this side piece. So for that, watch what's going to happen. First of all, there were fillets here. So I definitely need to extend this just a little bit before I do my trimming. Did that work? Yeah, I think that did actually. There it is. And you'll notice that when I do my trim, actually that's working fine. You're not going to notice anything. It worked just fine. So this is looking really good, except when I show the original had that fillet running all the way up it and down it here. And so I want this one to also have the same. So what we'll do is we're going to stitch this all together, something like that. Now it is one surface body. That's looking pretty good. And I don't know what that one is. We don't need that. And then we'll go and add our fillets. Now, I believe I already measured this once, so I believe this is going to be a 0.5 millimeter fillet. That's pretty good. I believe this one on the top is going to be 0.4 if my memory serves me right. And I'd just go and measure this if I didn't remember. That's pretty good. So now I have those fillets, and I'll go and look at this. And I see a little bit of funniness going on here. We're about to fix that, and we'll be done. I'll take this surface and extend it by millimeter. Yep. And then I'll go and use my ruled surface right here. I'll choose normal. And we're just making a tiny little chopping surface, so to speak, or surface to be able to use for chopping. I'm going to do the same thing down below. Yeah, it looks like I need to. I'll go and take this. We'll extend it a millimeter. We'll go and use my ruled surface. We'll make that a millimeter. Good. We can hide this. And when I trim it, watch what, well, first of all, we should untrim this. Whoa, that was a little weird. Let's put that back to 0. When I trim this, it might try to trim more than what I want. So I can untrim this fillet right here, use this as my trim tool, and just affect that area, delete my tool. Same thing over here. We're going to untrim this. We are going to use this as my trim tool, get rid of my tool. I don't need that anymore. I can stitch all of this back together. And I'm going to cross my fingers that this works with our very limited time here. Oh, actually, we have one more funny thing going on here. We're going to unstitch whatever this weird thing is, and we'll get rid of that. That'll be this. There we go. Okay. So if all goes to plan, now I can go and stitch this back together. I should see all my edges stitching. And guess what I have? I have a solid. And if we compare the original to what we have now, you'll see that angle difference right there. Exactly what we wanted. And doing something like this, I'll tell you right now, is solid modeling nearly impossible. Surface modeling is the trick to being able to do this effectively. So I think that's really the key there. Last thing I'm going to show you guys, because this was all the surface modeling, is again about the prototyping with my 3D printer. If I'm ready to go and 3D print this, I'll just go and pull up a web browser. Right, we have our FXR Racing right there. I'm going to pull up my bookmarks for a moment, and I have a bookmark for my Makerbot cloud print. I have another 3D print ready to go. You'll see that my printer says it's ready for printing. I have another one right here in the queue. And if I want to start this, all I have to do is say start print job, start. And the beauty behind Makerbot's Method X being cloud connected is that in the background already, it's starting to go and heat my build chamber, and it's going to go and start my print. And it turns out in, let's see how many hours this one's going to take. In 6 hours and 14 minutes, my next print is going to be done. I'm going to get an email telling me that it's ready for me to go and take it off the build chamber. And of course, I could go and start printing my next thing. So we covered a lot today, a lot today. And I just want to say thank you for joining us today. Today was intermediate surface modeling with Makerbot Method X as well as with FXR Racing. If you liked what you saw today, please like our video. And we are happy to do these, and we're going to do another with even more advanced surface modeling. So thank you all for your time today, and don't forget, with Fusion 360, you can make anything. Have a good one.